Hey everyone, now we are going to talk about the observer pattern. And to make things really interesting, let's start with an example right away. So let's imagine we have a game, and in this game, we have a character named Tom. Tom has 3 lives in the game, and also a memory that contains some words that he has learned. In our game, Tom has to avoid bowling balls that are going to move towards him in high speeds. Collision between Tom and the object have some severe consequences. Firstly, each hit takes 1 health point from Tom, and secondly, it makes Tom dumber because he loses learned words. This event is not good at all for Tom, as you can see. But our main question is that how will we implement handling this event to reduce class coupling and to provide clean and consistent solution in general? You may have assumed, and I think your assumptions are correct, that this is the time and place for the observer pattern. Because the observer pattern has the intent to define a one-to-many dependency between objects, so that when one object changes state, all its dependents are notified and updated automatically. So keep in mind that when one object changes state, then all dependents are notified and updated. These are the keywords actually, what you should remember when talking about observer pattern. And also you have to know about the general structure of observer pattern. As you can see, there are 2 main classes for this pattern. The first one is the subject class, and the subject class is for adding or removing the observers from the subject observer list or any other data type that you can use to keep elements inside them. And finally, but not least, to notify all the observers with events that have happened. And secondly, the big class in our pattern is the observer class itself, and it has an update method, and this update method actually reacts to these notifications that this notify event sends to observers. And this is actually the general structure of this pattern. So you can see that I talked about the abstract classes, but every abstract class has its concrete class which realize the methods and the logic the parent class has. But now we know about something about the observer pattern. Now we can actually continue with our small example to get to know more or get a better understanding about the observer pattern. So we had our character called Tom. Actually, Tom is our subject, and Tom had his health. So he had 3 health points. That means he has some kind of a health component or something like that, which contains this health value, and also in the graphical user interface it has some kind of a health objects. And for that to to observe these objects and these variables, we have a health observer. And also for the memory, we have the memory observer. So when something happens with health or memory, these observers react or do not react to some events. So in our case, when the bowling ball hits our DOM, then firstly the DOM notifies all the observers about this event, this nasty little event, and now the health observer firstly gets this notification and then acts accordingly. In our case, it takes away 1 health point from DOM, then updates the graphical user interface. Also, it depends what logic it has written inside it. But in our case, it just took away 1 health point from DOM, and our memory observer actually took away some words, cat and dog, from the memory. And this is the example that should make things more clearer for you about the observer pattern. The bottom line is that when some event happens, then we want to notify all the observer that this event has taken place. We don't care what is to be done about it. We just notify every observer, and if any observer has some logic, something to do about this event that we have notified it about, then it must do it right now. And this is actually what I wanted to say about the observer pattern, but there are some benefits when using observer pattern. First of all, the loose coupling between modules. Our subject does not have to know the class type of an observer. We can use any kinds of observers. We can broadcast communication. And finally, but not least, the model view controller frameworks are actually founded by this observer pattern. And if you don't know about the model view control pattern or frameworks, then do not worry, you are going to learn about them. You can Google it up right now really quickly, what they mean, and you can see that a lot of applications actually use this model view controller framework. So observer pattern is a really influential pattern because it's the foundation to this model view controller frameworks or pattern. But as with great responsibility, with great power comes great responsibility. So is with observer pattern, because observer pattern also has some things you should keep in mind. First of all, the method calls are synchronized, and this means that you have to be careful because the observer pattern is synchronous. The subject invokes its observers directly, which means it doesn't resume its own work until all of the observers have returned from their notification methods. A slow observer can block a subject, and this is a big problem. And when you delete an observer instance, doesn't mean that automatically you are detaching the observers from the subject. No, you have to do them yourself manually. And garbage collector actually does not clean up them. So you have to be careful because this can lead to lapsed listener problem, which is a common source of memory leaks for object-oriented languages. And to avoid this problem, you should always detach observers. actually this is everything I wanted to talk about observer pattern. I hope you got a better view about it. I think that our task in the gglearn will help you to understand more about it. But one last thing is that actually the observer pattern is really popular. How can you see it? Is that it's implemented in C# and Java. By this I mean that they are built in C# and in Java. So when you want to use this pattern, this system in C# or in Java, you can use the already built-in methods and keywords. But in our course we are not going to use them, because you are here to learn about this pattern and you want to get the feeling about this pattern, you want to get the flow, how it works overall, and for this you have to implement it yourself. But keep in mind, in the future when you want to use something like this, then just Google it how it works, and you don't have to reinvent the wheel. And now your to-do list is to read the Observer chapter from Game Programming Patterns and gglearn, and do the Observer tasks from gglearn also. You have 2 weeks to do it, and this time you have to form teams. So you can't do it alone. You have to find one team member to do this task. I recommend you start searching for teammates in this lab session. So because everyone are here right now. And yeah, this is actually why we are doing this, is because teamwork is important in the future. If you are not going to do it right now, you don't want to do it later, because communicating and working together, these skills are very important. And finally, I also recommend you reading the dirty flag pattern for optimization, as this dirty flag pattern and observer pattern are used together. So this is your to-do list. I suggest you to start reading first and then doing the task, and I wish you good luck.